An official alert goes out. Observatories across 3 continents receive the notification simultaneously. Priority observation status, all available instruments, maximum data collection protocols. The target, an interstellar comet that has just violated another fundamental principle of physics that scientists believed was unbreakable. This isn't the first anomaly from 3I Atlas. We've watched it erupt where it should be frozen. We've measured chemistry that shouldn't exist at these temperatures. We've documented brightness fluctuations that match no known pattern. But what happened in the last 72 hours crossed a new threshold. Something so unexpected that NASA's Planetary Science Division issued a formal statement acknowledging that existing thermal and compositional models cannot explain what multiple independent instruments are now measuring. When space agencies issue alerts like this, it means the rule book just got thrown out. And somewhere beyond Mars, an object from another star system is showing us exactly how little we actually understand. November 1st, 2025. NASA's Neil Gehrels Swift Observatory completes a routine scan of 3I Atlas position. The spacecraft, designed to detect high-energy ultraviolet sources across the sky, has been monitoring the interstellar comet since its unusual activity first appeared weeks ago. But this scan reveals something different. The hydroxyl emissions have intensified, not gradually, not following any thermal curve predicted by models, dramatically, as if someone turned up the power. The Swift team runs diagnostic checks. They verify calibration against known standards. They compare the signal to previous measurements. Every test confirms the same conclusion. 3I Atlas is releasing water vapor at rates that have increased by a factor exceeding previous observations, despite moving farther from the sun and receiving less solar radiation. This violates basic thermodynamics. Objects cool as they recede from heat sources. Activity should decrease, not intensify. Yet the data is unambiguous. Within hours, NASA issues the alert. Hubble Space Telescope receives priority targeting instructions. Ground-based observatories in Chile, Spain, and Hawaii redirect their largest instruments. The James Webb Space Telescope clears observation slots. Because if this measurement is accurate, if it's not some instrument artifact or calibration error, then something is powering 3I Atlas that has nothing to do with solar heating. Subscribe now, because what these instruments are about to reveal will fundamentally change how we think about interstellar objects. 48 hours after the Swift alert, Hubble's Wide Field Camera 3 locks onto 3I Atlas coordinates. The imaging sequence begins. Multiple exposures across different wavelengths. Polarization filters capturing how light scatters off the comet's dust. The results arrive at the Space Telescope Science Institute in Baltimore. Researchers open the files expecting to see the familiar jet structure documented in previous observations. What they see instead stops conversations mid-sentence. The jet has changed, not in orientation, not in structure, in intensity. The column of gas and dust erupting from the nucleus has brightened significantly. More material is being released. The coma has expanded. And this is happening at 3.1 astronomical units from the sun, where surface temperatures hover around negative 150 degrees Celsius. One researcher describes it later as watching ice cream melt in a freezer. It shouldn't be possible. Yet there it is, captured in multiple independent exposures, time-stamped and archived. The Hubble data confirms what Swift detected. This isn't measurement error. This isn't instrument malfunction. 3I Atlas activity is intensifying as it recedes from the sun, in direct contradiction to every principle of cometary thermodynamics developed over centuries of observation. Dr. Tony Farnham from the University of Maryland, who has studied comets for over 2 decades, provided a statement to NASA's Planetary Science Division. 3I Atlas gives us our first chance to study interstellar ice chemistry under controlled conditions. What's most surprising is the persistence of jet activity at distances where standard thermal models predict complete dormancy. But even that careful phrasing understates the problem. It's not just persistence, it's intensification, it's acceleration. It's behavior that requires an energy source completely independent of solar heating. The James Webb Space Telescope brings capabilities that neither Swift nor Hubble possess. Its infrared instruments can analyze chemical compositions with unprecedented precision, detecting molecular fingerprints invisible to optical wavelengths. Webb's spectrometer points toward 3I Atlas and begins collecting photons. Each wavelength carries information about what molecules are present in the coma, what temperatures they indicate, what processes are driving their emission. The spectrum reveals the now familiar carbon dioxide dominance, 8 parts carbon dioxide to 1 part water, an inverted ratio compared to typical solar system comets. This chemistry alone suggests formation in an extraordinarily cold environment, possibly around a star far dimmer than our Sun. But Webb detects something else, an absorption feature at 4.5 micrometers that matches nothing in existing cometary databases. Not water ice, not carbon dioxide, not methane, ammonia, or any cataloged volatile compound. An unknown substance, or a known substance behaving in unknown ways under conditions we've never observed before. This unidentified feature appears consistently across multiple observation sessions. It's not noise. It's not instrumental artifact. It's a real absorption line indicating real molecular bonds, real chemistry, real material that we cannot identify. And here's what makes it significant. That feature intensifies in parallel with the overall activity increase. Whatever is causing 3I Atlas to erupt more vigorously as it recedes from the Sun, this unknown compound is part of the process. Comment below, how does it feel knowing there's chemistry happening in our solar system that we can't identify? While NASA's space-based telescopes track the chemistry, the European Southern Observatory's very large telescope in Chile focuses on the dust, specifically how that dust interacts with light. The SPHERE instrument, designed for polarimetric analysis, measures the angle at which light's electric vector rotates after reflecting off particles in 3I Atlas coma. This reveals information about particle size, shape, composition, and surface properties. Previous measurements showed negative polarization, already unprecedented for an interstellar object, already suggesting particle properties fundamentally different from solar system comet dust. But the latest measurements show the polarization angle has increased, not to 0, which would indicate a return to normal behavior, deeper into negative territory. Now, measuring negative 18 degrees, confirmed by both the Very Large Telescope and Hubble's polarimetric filters. This isn't just unusual dust. This is dust that responds to light in ways that violate standard scattering theory. The particles must be either extraordinarily fine, perhaps nanometer scale grains smaller than anything found in local comets, or composed of materials with optical properties we've never encountered. Either way, it indicates that 3I Atlas formed from materials processed under radiation environments, completely unlike our Sun's. Different stellar spectra, different photochemistry, different everything. And as the comet's activity intensifies, more of this exotic dust is being released into space. The coma is growing, the particle density is increasing. We're watching material from another star system fill a region of our own solar system with substances that don't behave according to the rules we've written. Let's be precise about what's breaking. What specific physical principles are being violated? Thermodynamics, the study of heat and energy transfer, one of the most fundamental branches of physics, based on laws that have been tested billions of times across every conceivable situation. Laws that say objects cool when they move away from heat sources. Energy flows from hot to cold, never the reverse without work being done. 3I Atlas is currently 3.1 astronomical units from the Sunday. It's receiving less solar radiation than it did weeks ago when it was closer. It should be cooling. Its activity should be decreasing. Instead, it's intensifying. More vapor, stronger jets, brighter coma, as if it's getting warmer despite moving into colder regions. This requires an energy source, something providing heat or chemical energy to drive sublimation, something independent of solar radiation. Possibility 1, radioactive decay. Some comets might contain radioactive isotopes that generate heat through decay, but the quantities required to explain this level of activity would be enormous, and those isotopes should have decayed over the billions of years since 3I Atlas formed. Possibility 2, exotic ice chemistry. Perhaps the unknown compound detected by Webb releases energy when it transitions between states. Perhaps the carbon dioxide dominance creates chemical reactions that generate heat, but no known ice chemistry produces endothermic reactions strong enough to explain this. Possibility 3, internal pressure. Perhaps the nucleus contains subsurface voids filled with volatiles under pressure. As solar heating penetrates, these pockets vent explosively. But pressure venting should be brief and sporadic, not sustained and intensifying. Possibility 4, something else, something not included in our models because we've never encountered it before. A process or mechanism that operates in interstellar objects but not in solar system bodies. Each explanation has fatal flaws. Each requires assumptions that contradict other observations. The physics that explains everything else we've studied fails to explain 3I Atlas. This is how science advances, not through confirming predictions, through encountering phenomena that break existing frameworks and force us to build better ones. Overlaying all these chemical and thermal anomalies is the brightness problem. 3I Atlas doesn't just glow steadily like normal comets. It flares. Short-term brightness increases, lasting hours to days, then returning to baseline, occurring without warning, showing no correlation to rotational period or solar distance. These outbursts suggest rapid releases of material from the nucleus, sudden venting events. But what triggers them? Normal comets occasionally show outbursts when surface crusts crack, exposing fresh ice underneath. Solar heating vaporizes this newly exposed material quickly, creating a brightness spike. Then activity returns to normal as a new crust forms. But 3I Atlas outbursts don't follow this pattern. They're too frequent, too irregular, and they're happening at temperatures where surface crust shouldn't crack because the ice underneath should be just as frozen as the crust itself. Ground-based telescopes in Chile and Spain have been monitoring continuously, hoping to catch an outburst in real time and measure its evolution. Some flares have been captured. The data shows brightness increasing by factors of 2 to 3 over just hours, then declining over days. This time scale suggests rapid gas release followed by gradual dispersal, but the trigger mechanism remains unknown. What causes the sudden venting? What determines when an outburst occurs? NASA's latest observations show these flares are becoming more frequent as the overall activity intensifies. More outbursts per week than in previous months, as if whatever internal process is driving them is accelerating. A fortunate alignment is about to provide unprecedented data. NASA's Europa Clipper spacecraft, launched to study Jupiter's ice-covered moon Europa, is currently traversing the inner solar system on its multi-year journey to the outer planets. Mission trajectory calculations show Europa Clipper will pass through regions of space containing charged particles and dust released by 3I Atlas. The spacecraft's plasma instruments and particle detectors, designed to study Jupiter's magnetosphere, can also sample this interstellar material. NASA's Heliophysics Division has coordinated with Europa Clipper mission controllers to activate all relevant sensors during the passage. Particle mass spectrometers will measure composition Charge detectors will analyze electrical properties. Dust sensors will count grain sizes. This will mark the first time a spacecraft has directly sampled material from an interstellar object within our solar system. All previous data comes from remote sensing. Telescopes measuring reflected light, spectrometers analyzing emitted radiation, indirect measurements requiring models to interpret. Europa Clipper will fly through the actual material, collecting particles, measuring them directly, removing the interpretation layer between observation and understanding. The data could reveal isotopic ratios that indicate where in the galaxy 3I Atlas formed, charge signatures that explain the polarization anomalies, chemical compositions that identify the unknown absorption feature Webb detected. Or it could deepen the mystery further, because every time we get closer to 3I Atlas, every time we gather better data, the object becomes stranger rather than more familiar. 3 interstellar objects have now passed through our detection network, each one completely different, each one challenging different assumptions. 1I Oumuamua arrived first in 2017. Its behavior sparked intense debate, no visible activity, no cometary coma, yet slight acceleration beyond gravitational predictions. Rocky asteroid, inert comet, or something else entirely? The questions remain unresolved because it faded from view before comprehensive studies could be completed. 2I Borisov followed in 2019. This one was reassuring. Classical cometary behavior, water ice sublimating predictably, coma and tail forming at expected distances. Chemistry matching solar system standards. It proved that interstellar comets could be conventional, following rules we understand. 3I Atlas destroys that reassurance. It's neither inactive like Oumuamua, nor conventional like Borisov. It's active, but wrong. Chemistry inverted, thermal behavior contradicting models, brightness fluctuating inexplicably, dust polarizing light impossibly. 3 visitors, 3 completely different profiles. What does this statistical sample tell us? That interstellar objects display far greater diversity than solar system objects. That formation conditions around other stars produce outcomes wildly different from local examples. That our theories, built on studying objects from one star system, may not apply universally, or that we're encountering things that don't fit our categories because the categories themselves are based on incomplete understanding of what's possible. Let's return to the fundamental question. Where is the energy coming from? Scientists have calculated 3I Atlas energy budget, how much solar radiation it receives, how much energy that radiation can deposit into surface ices, how much sublimation that energy can drive. The calculations are straightforward. At 3.1 astronomical units, solar flux is approximately 9% of what Earth receives. Surface temperatures should stabilize around negative 150 degrees Celsius, assuming standard ice composition and thermal properties. At that temperature, water ice cannot sublimate. Carbon dioxide ice begins sublimating at around negative 78 degrees Celsius at low pressure, but even that threshold isn't reached at this distance. Yet 3I Atlas is releasing material at rates measured in tens of kilograms per second. That sublimation requires energy. Latent heat of vaporization must be supplied to transition ice from solid to gas. The solar energy input is insufficient by orders of magnitude. The numbers don't balance. Energy is being released from somewhere else. Internal radioactivity requires isotope concentrations that should have decayed long ago. Chemical reactions requires exotic chemistry we haven't identified. Electrical phenomena requires charge accumulation and discharge mechanisms with no clear source. Every proposed energy source faces quantitative problems. The numbers don't add up. The energy budget fails to close. And when budgets don't balance, either the measurements are wrong or the framework is incomplete. Multiple independent instruments confirm the measurements, which means the framework needs revision. When NASA issues formal alerts to observatories worldwide, it's not routine communication. It's acknowledgement that something significant is happening that requires coordinated response from the global astronomical community. The alert for 3I Atlas went out because the latest observations crossed a threshold. This isn't just an unusual comet anymore. It's a phenomenon that existing physics cannot accommodate without major theoretical revision. The alert requests maximum data collection while the object remains observable. Spectroscopy across all wavelengths, imaging in multiple filters, polarimetry from multiple facilities, continuous monitoring to catch brightness fluctuations. Because every measurement might be the one that provides the key insight, every data point might reveal the pattern that makes everything else make sense. Or every measurement might add another layer to the mystery, demonstrating that 3I Atlas is even stranger than current data suggests. The window is closing. By mid-November, the comet will fade below detection thresholds for most instruments. Its outbound trajectory carries it at 31 kilometers per second, moving farther from the Sun every moment. Soon it will be too dim to study, too distant to measure. This is humanity's only opportunity. No spacecraft can intercept it. No future mission will visit it. The data being collected now will be the complete record of 3I Atlas, the foundation for every future analysis and every theoretical model attempting to explain it. Step back from 3I Atlas specifically. Think about what it represents for our understanding of the universe. We've studied solar system objects for centuries, thousands of comets, millions of asteroids, detailed observations building comprehensive theories about how these objects form, evolve, behave. Those theories work beautifully for local objects. They predict brightness curves. They explain chemical compositions. They model thermal evolution. For solar system bodies, the physics is settled science. Then 3 interstellar visitors arrive, and none of them behave according to the rules we've written. This reveals something profound. Our theories aren't universal. They're local. They describe how objects formed in one stellar environment around one particular star. They may not apply to objects from different environments. The galaxy contains hundreds of billions of stars, each one potentially creating unique formation conditions, different temperatures, different chemical abundances, different radiation environments, different everything. The objects forming around those stars will reflect those differences. They'll display chemistry we haven't cataloged, physics we haven't modeled, behavior we haven't predicted. 3I Atlas is teaching us humility, showing us that our comprehensive understanding of comets is actually a narrow understanding of solar system comets, demonstrating that the universe is more diverse, more creative, more surprising than our theories accommodate. As I record this, 3I Atlas continues breaking rules, releasing vapor where it should be frozen, glowing brighter as it recedes from heat, displaying chemistry that doesn't match any database, polarizing light in directions that violate scattering theory. NASA's alert remains active. Telescopes worldwide continue monitoring. Data accumulates in archives that researchers will analyze for years to come. Trying to solve a puzzle that grows more complex with each measurement, the physics isn't actually breaking. Physics describes how the universe operates, and the universe doesn't break its own rules. What's breaking is our understanding, our models, our assumptions about what's possible and what's not. 3I Atlas is showing us where those assumptions fail, where our theories, built on limited experience from one star system, prove insufficient to describe objects from the vast diversity of galactic environments. This is uncomfortable. Science prefers confirmation to contradiction. We like it when observations match predictions, when models work, when the universe behaves as expected, but contradiction is how science advances. 3I Atlas is advancing our science right now, forcing us to expand frameworks, to consider new mechanisms, to build better theories that can accommodate both familiar solar system objects and exotic interstellar visitors. The alert NASA issued isn't a warning of danger. It's an announcement of opportunity. an object from beyond our planetary neighborhood, is revealing gaps in our understanding, showing us what we still need to learn, teaching us that the universe contains phenomena we haven't encountered yet. Comment below. What do you think 3I Atlas will teach us that we couldn't learn any other way? And subscribe, because this story continues evolving. The Europa Clipper passage approaches, the observation window closes, and somewhere beyond Mars, an interstellar visitor keeps demonstrating that physics is far richer, far more complex, far more surprising than any textbook can capture. The rules aren't breaking, they're expanding, and 3I Atlas is showing us exactly how much room there is for expansion.